Hi, everyone. Welcome. Thanks for attending this rebroadcast session of session Sridhar and I did a little bit ago about GraphQL security. Turns out it was popular enough that some people wanted us to show it again and set it up. So we're doing that today. Sridhar and I will be live online, ready to answer questions. And with that, I will start the broadcast. Thank you. Hi, everyone. Thanks for joining us again for another session in our GraphQL architecture discussions. Today, we're going to be talking about security risks related specifically to GraphQL, but also sort of to APIs in general, because we know that that's obviously a concern for all of us who are working with GraphQL. My name is Carlos Eberhardt. I'm on the customer success team at StepsIn. And I like that title because it gives me a lot of leeway in terms of how I work, either with companies that are our customers or might be our customers, or with our own company. Having the voice of the customer inside a company is always a fun spot to be. And that's something that I've done for the past decade or so at various companies, primarily working with very large enterprises, Fortune 1000, 500, etc., and bigger companies. I've had a lot of experience working with these companies as they kind of take an API journey, and now they're starting to look at GraphQL APIs, and it's given me a broad perspective on sort of the things that they care about and the issues that they run into. Today, joining me, I asked Sridhar, our CTO, to hop in because he also has a lot of experience and much deeper and more technical experience than I have in this same area. So Sridhar, why don't you say hello?
Hello, folks. It's great to be here. I'm Sridhar. I'm the CTO of StepsIn, and I wanted to be here to also, like Carlos, I've spoken to many customers over the many years that I've been working, and I have some maybe collected insights from all those conversations, especially about security and what it means to be able to deliver security in real terms. So I'm hoping that I'll be able to share some of that with you today. Carlos, back to you.
Great. Thanks, Sridhar. I hope so too. So today we'll start off talking about sort of there's a bit of a prevailing attitude out there about GraphQL and security. So we'll talk about that a little bit, and then we'll dive into some specifics related sort of to APIs in general, some GraphQL specific concerns, and we'll talk about some mitigation strategies. And I'll show you a very short example of that visual to kind of bring some of those strategies to life in front of you, and then we'll have some time for Q&A, of course. And as always, since we're running through things, and it's unfortunately we're not having a live conversation with you. If you have questions, please drop them into the chat, and we'll address them throughout the broadcast or at the end. And of course, you can feel free to say hi to other people there and introduce yourselves, and we'll just go from there. So one of the things that I first heard when I started looking at GraphQL, and actually I had a little bit of this attitude myself, to be fair, was that it was less secure. GraphQL is less secure, or it's a security risk. I heard that a lot with customers, and I can understand where that was coming from, because at least from my perspective, I was looking at it as compared to a REST API. And when I saw how GraphQL worked, I thought, well, wait a second, GraphQL has an entire graph of capability underneath one endpoint. And I was used to REST APIs where I would have different endpoints for different capabilities. And I could protect those endpoints using relatively standard things that I knew how to do. Authentication and authorization is important. Since it's over HTTP, worrying about standard HTTP attacks matters. Thinking about things like cross-site scripting and all of the standard kind of security things were relatively easy to understand and kind of well known. And then when I thought about GraphQL, I thought, hey, suddenly now there's I can get at everything that I used to expose under maybe a dozen APIs, maybe more, under one endpoint. How am I going to make sure that I'm taking care of everything that I need to worry about for HTTP. I understand that, but when it came to GraphQL and thinking about, well, wait a second, I can't just use a single authorization method then, because the request is generally the same. It's what's inside the request that needs to be managed. So I was a little bit worried that it was actually just, it was impossible. It was going to be less secure. But thinking about it, it actually does give you an opportunity to if you're thoughtful about the design of your schema, you can really control that, and it doesn't need to be less secure.
Carlos, that's actually a really good point. And if you design something and your security schema together, you may actually end up with an opportunity rather than a risk here, and you'll have a consistent security model that you can reason about across all of your assets, right? As opposed to having to mind multiple endpoints and making sure that they stay aligned with each other. And in a way, if you do this well, you can actually end up with a more maintainable and more secure system. So I think that's a very possible outcome.
I wish I had thought about it that way at the start. And as you said that, it kind of struck me that when it used to be sort of security was kind of something that was done after the API a lot of times. So it was like, okay, the API does what I want. Now I need to secure it. And what you just said is, if I'm thinking about security as I'm designing the API, I can actually have a much stronger security position than if I consider security to be something that I do after the fact. Is that kind of what you were getting at?
Exactly. And that security should be a part of your thinking process, just as your API should be beautifully designed. And GraphQL allows you to design and build a consistent API across all of your information. A part of that design process can also be all the considerations for security.
For security, that makes sense. So another way to say it, right, is it's not inherently less secure, just by its nature, but if you don't think about it, it could be, right? I guess the last bullet point here is it's easier to be careless and cause big problems with an API that has kind of one endpoint that can do everything versus a bunch of separate endpoints.
The flip side of it, of course, Carlos, is what we just spoke about, which is you could get a lot of benefit from being thoughtful.
Right. Sure. So yeah, if you start with the mindset that I'm designing this API not only to solve a business problem, but at the same time I'm doing that, I'm thinking about how secure it needs to be and what type of rules I need to have in place, that actually ends up taking work away from me, because I don't have to go in after the fact and then say, okay, well, wait a second, now I need to figure out how I'm going to authorize users to get this endpoint versus that endpoint. I've already done that work up front, right?
Yes.
Yeah, great. Okay, perfect. So let's talk a little bit then about some of the sort of the standard API security concerns. And I wanted to drop a few sorts of things in so that we're all kind of talking on the same page. I do think security is fairly well understood today. Security as a topic is something you can never really be done with, but you can at least have a pretty good sense of reasoning about things that need to be done. And those things that need to be done include, having a strong authentication and authorization framework in place. And I added a little comment here, so, don't confuse the two. A lot of times people kind of put them together into one thing. And I think it's important to understand that just because a user is authenticated doesn't mean they're authorized to do something. And treating those as sort of separate capabilities is important. Obviously, as I mentioned, the standard kind of network attacks that you need to worry about are there. The level of exposure that you're going to have is going to vary. Obviously, if you're doing things just internally inside your own firewall, you can rely on that firewall to do some work for you. But I still think it's important, even if you're doing that, to consider, what happens if someone gets through that firewall. Maybe we do want to add an extra layer. More security, I don't know, is it's not always a bad thing, right? To have some redundant measures in place. And then also, we've got organizations like OWASP that have been doing great work for a long time in helping us understand, the types of attacks that we're seeing in the world and how to mitigate those. So it's important to kind of, from a recommendations perspective, we should continue those best practices. If you're starting with GraphQL, or if you're thinking about converting some of your existing APIs into GraphQL, don't throw away the work that you've done to make sure that those things are secure, and don't throw away the work that other people have done, like the OWASP group, in terms of recognizing the types of attacks that can be there. So do things. Standard stuff, protect against cross-site scripting, and make sure you're doing input validation and preventing SQL injection, by using prepared statements, for example. All of those techniques are valuable, and you should continue to use those as you think about GraphQL. Infrastructure as well. So not just on the coding side, but if you've got, Nginx or the like sitting in your network infrastructure doing, various checks and filtering on requests, keep doing that. Usually that stuff is very fast and very performant. Adding a layer of security is not it's not a bad idea from a performance perspective either.
Yeah, it's a really good point. I mean, if you're a skydiver, then you would test your spare chute. You would carry your spare chute, even though the main one's plenty good.
Yeah.
And it's the same sort of thing, right? There's no need to remove your backup, validations, checks, and security best practices. Whatever you've built already is good, even when you layer GraphQL APIs on top of existing.
On top of it.
Yeah.
Yeah, and I guess that's important. Then it gives you another opportunity, right? From that GraphQL perspective, I can make sure that I'm still, even if I'm building GraphQL on top of a REST API and my resolver is making an API call like that, I can still rely on that API to do its job of protecting, as well as when I'm protecting on the GraphQL side. I think that's a really good point. The other thing that I know, bigger companies that are doing a lot of work with APIs often invest in API management tooling. And we're seeing more and more of those starting to provide GraphQL specific capabilities. I know that Apogee, for example, has some policies that are GraphQL specific for protecting things. I believe Kong is getting into that space as well. And I'm sure there are more. I haven't been following that quite as much, but those companies, obviously, there's value that they provide for people. And as more and more people are looking at GraphQL APIs, they're recognizing that there's value they can provide to the GraphQL world as well. And then I guess the final thing I would say regarding security is that, to test, monitor, and automate, I don't know if that's a little phrase, but I use it a lot, is in that it's super valuable to have specifically automation on a lot of the things that you do. So as you're designing stuff, you've got a concept in mind that says, hey, I want to prevent this from happening. It's not hard to write a test that does that and make sure that it works, but then, automating that so that every time I roll out a release, I'm making sure that I haven't made a change that causes some regression I wasn't expecting. I think that's super important.
Yes, and human errors are going to happen. They don't happen for any reason, and to the extent that you automate testing, you make it less likely that a human error will percolate all the way to the end. Yeah.
Perfect. Yep. So let's talk about then. We kind of got a pretty good handle on sort of the standard API stuff, which does, because GraphQL is over HTTP. I think a lot of it really does apply. But there are some, now that we've added a single endpoint with a large graph, large or small, it's up to you, with different nodes and different edges connecting those nodes, there are things that you might not want to happen that can happen. And I tend to bucket those into sort of three big things. One of them is information leakage, and that I kind of equate that to thinking about sort of a security through obscurity. I used to think, hey, what's the big deal with having a documentation available so that someone, it's nice when people can figure out how to use things. But there is some value to it in terms of, if you think about the unhappy path of someone who's trying to do things you don't want them to do, making their job easier is not always the best choice. So while I consider information leakage to be a little bit of a security through obscurity, which is not necessarily it's not all you can rely on. I do think that there is value in thinking about what you want to make available to people, and we'll talk about some of these in a little bit more detail coming up. And then there's request complexity, and that's really, when thinking about a REST API, you can provide query parameter flags that allow people to change the way that request works, but it's generally, you're in a much smaller domain. It's a lot easier to understand that, hey, I'm not going to let someone basically try to download a database through my REST API. But with GraphQL, because of the way you can define that schema and make relationships between types, you can actually build up a request in GraphQL that's relatively complex, and that can show up in different ways. You can batch requests together in a single GraphQL call. You can nest things very, very deeply, follow that path. If we look at the orange dots on the picture, that's the type of thing that you can kind of do in a single request. So there's and then there's just complexity in terms of what is happening on the back end. So maybe my request isn't necessarily a bunch of things batched together or really deep, but the way I've made that request, I've got kind of that N+1 problem. I'm generating 10,000 requests to something on the back end. So there's that one, to me, is a little bit more complex in solving and requires more thoughtfulness. And then finally, there's this authorization. I can call it authorization plus because it goes beyond authorization just for making the request. It's what is in the nature of that request that I'm asking for, and am I authorized to get all of that? If you can imagine, if I had a large graph that connected customers and orders, and customers had detail to purchasing records and things like that, I may not want everyone to be able to just dive right in and find all of that detail, even if it's just purely internal. Obviously, we have security controls in place on data for a reason, so it's important to be able to carry those same security controls through into your GraphQL API. So if we talk about information leakage, and there's a few things here that kind of sort of the big buckets that this falls into typically with GraphQL is the introspection. If you're not aware, GraphQL has what I think is a great feature that allows you to actually query the graph that says, hey, not only can I get specific information from sources, you can give me metadata about the graph itself. What types are available and what kind of things can I ask for? That's really very interesting, I think, from an API perspective. It's almost like live connected documentation, and it allows you to really navigate an API when you're just learning something kind of nicely. It does, however, though, if you're not controlling it, it tells you everything that's there. You can create a query that tells you to a great detail about the types and connections that are in your API. Another thing with that GraphQL can do is servers will often make field suggestions for you. So if I ask for, if say I'm querying for a customer and I say name, and there is no name in that type defined, the GraphQL server might say, hey, there is no name. Did you mean customer name? Which is handy. It's nice. It's a nice thing to do for people. But at the same time, if you think about it from someone who's attacking what you're doing, it gives them the opportunity to start sending in a bunch of fields that they may not know exists. If you've turned off introspection, they don't know what's there. And those error messages, those field suggestions coming back, can actually reveal that schema as well. So you need to think about how you handle that. And then finally, error messages. GraphQL's got a great capability for returning error messages, even with partial responses. So I might get one query that's working and another one, or one part of my request is working and another part isn't. The error message can give me details. This is much like a REST API. You don't want to reveal backend implementation details about why that error happened. So you need to curate those a little bit and be careful to make sure that you're not revealing information, database names or addresses or things like that, that kind of stuff.
I think information leakage is also a kind of a two-edged sword, right? Because GraphQL, when someone asks a fairly sophisticated query in GraphQL, they're also giving you information about what their intentions are and what their intent is. And sometimes you can use that to stop exactly what you want to stop, while keeping everything else that you don't intend to stop easy to do. And I think, in a way, as security people, we often say that knowledge is of what the intent is, and what is one of the most important things to have as someone who's trying to build a good security practice. And it's much easier to design the right security framework when you can see what it can do. If you have the wrong one,
and you can see what people are trying to do, right? So you can exactly. I hadn't thought about that. That's interesting. So in my recommendations, right, I had common things of design your schema thoughtfully, and one of them, I'll come back to these a little bit. One of them I had was, again, automated testing, right? To put testing in place to look for this stuff. But what you just said means that you could also have monitoring in place to look for the types of kind of non-standard requests that you might be getting, right? And
things that you didn't expect, yeah.
Yeah, I didn't expect someone to try to do that. That's interesting. I wonder what our API does, or what did they see? And is this something we need to be concerned about? That's really important, right? In terms of, I'm thinking kind of, my mind right now is in just sort of design phase, right? Day one and not day N+1 kind of situations. But what you just mentioned is a great sort of ongoing practice in terms of continually thinking about security and using, the information that you're getting just from those requests to see the types of things that people might be trying to do. Yeah, that's really interesting. And so to come back up to the recommendations, design your schema thoughtfully. One of the things that I think a lot of people, there's good and bad about code generation, for example, right? It makes some things really easy and really fast. And I've even seen some of the AI code tools. There's been a little bit of argument in the world about this. Should I trust what one of these tools had just suggested that my function body be like? And I think the argument is, it's like, it can get you there, but you definitely want to be thoughtful about what you're doing. And I think it's the same with schema generation. So there are tools out there where I can point it at a database and it'll generate a schema for me. And StepSend is one of those. We have a tool that helps you do that as well. But I think at that point, that is not you're not done. That is the starting point for your schema design, and it automates a lot of kind of painful typing for you. But then you need to go back in and really think about the design to make sure that you're controlling what people can do and what people can see. Introspection is something that many servers allow you to disable completely. Again, I kind of like it still, so I like thinking about it from a protection perspective and using some of the techniques when we talk about authentication to allow only certain people to do introspection. Or maybe you only have it on in certain environments and you end up turning it off in production, for example. But I think it's important to consider it and not just kind of go with out of the box, having it wide open all the time. Disabling field suggestions, there's different ways to attack this. A lot of the servers that, if you're writing your own code, there's switches that you can flip to make sure that doesn't happen. And again, don't simply return errors as is. Don't spit out, interesting information in your errors that someone might use. I know one of our engineers, Charlie, is really good at thinking about this, and that when sometimes it can be a detriment, right? You can think as a user, gosh, I'd really like to know what exactly went wrong. And I've asked that to Charlie a couple of times. And he said, yeah, you would, but so would someone who's trying to break in. And we need to think about both cases and balance those. And again, of course, we talked about automated testing and monitoring as being that's kind of running through this whole theme is making sure that you're thinking about security from the start, and that means even writing tests for it and automating them. So let's request complexity is the next one we had to talk about. And again, this is multiple operations in a single request, nested queries, query complexity. These are the types of things that I think make GraphQL great. Honestly, I really like being able to fire off multiple operations in a single request, especially if it's unrelated data and I just want to get it back in one pull. That's terrific. Nested queries, it's fantastic. I'd much rather be able to, if I'm pulling up a customer record from my database and the orders table and customer tables are connected by a foreign key, I'd rather have one GraphQL request that gets me exactly what I need rather than retrieving a customer, searching for a name and getting their ID and then making a request, a second GraphQL request using that ID, that kind of thing. Nesting those things, linking those or stitching those types together, and allowing me to make that request in one shot is super valuable. Getting rid of this kind of stuff from GraphQL would really hurt the API, I believe. And again, query complexity in terms of what does the query do to your server and the systems behind it? Not necessarily is it a really big query, but is the nature of the query such that it generates a lot of activity? So again, solving these problems require you to think thoughtfully about your schema. I'll show you an example of this in just a second. Validating requests, putting some kind of rules in place that say, we can only do, I'm only going to allow you to go, 10 objects deep in a nested query, or maybe it's 5, maybe it's 3, depending on sort of what your schema is and how you've thoughtfully considered the design of that. And from a security perspective, you can probably come up with a fairly good idea that says, hey, if someone's trying to go 15 deep, they're doing something weird, or they're actually they're not trying to use the API, they're trying to exploit the API. So having the ability to just kind of slap some simple rules on top to reject those requests. And again, this is something that many servers have built in. API management platforms are starting to do this very type of capability so that rather than having it to live in your server, it can live at a level above. There's lots of ways to attack this. I think the number one thing that you should start with is having a timeout, because just simply saying, look, none of these queries should take more than 15 seconds to run or 30 seconds to run, even if it's reaching out to systems across the globe, and we're doing some fairly complex stuff. If it takes longer than that, this is unexpected, and we should have an eject button that basically says, no, we're done. We're not going to do that anymore. And that's kind of like the backup parachute in your analogy, Sridhar, I think, in that it's, if all else fails, at least I'm not, letting a request run away and opening myself up to a denial of service attack.
So Carlos, one of the things, I always think about is, request complexity and request sophistication, right? Mm-hmm. The reason why languages like GraphQL are useful, powerful, is because you can ask sophisticated questions and get the answers to them, and it enables you to build a user experience that brings together information from diverse places and put them on a screen and make the right information available at the right time. So as an application, you're far more convincing, far more useful, right? Mm-hmm. At the same time, there's the worry that when you allow sophisticated querying logic, or when you have sophisticated querying logic, you can use that to extract more information. So it's exactly that, right? That being able to allow things that are useful, important, and the bulk of the queries you will get will be the good stuff, right? They're actually delivering value by being sophisticated, or right? Versus, so this is why what you're saying, which is configuring the right timeouts, configuring the right security policies, right rules, right? That allow the use cases that are good, but don't don't have that much tolerance for things that are not in the right envelope, is important. And that's why I think the thinking has to happen up front, and you'll end up with a system that performs well, does the things that you want it to do in a very elegant way, but doesn't allow for exploitation. And because you've configured the right timeouts, the right exceptions, and all of that.
And all of that,
yeah.
I think that makes a lot of sense, and it reminds me again of what you commented about earlier about GraphQL being powerful from an information leakage perspective from an attacker. You can't necessarily, as an API builder or provider, imagine everything that API might end up being used for when you're starting. So having that monitoring in place and being able to see, this is an interesting request that came in. I don't quite understand why it took so long to solve this, or to why was the load for servicing this request? Why did it get close to what our boundary was, or why did it cross it, and why did we throw an error on it? Having that feedback loop in place that feeds from production monitoring and understanding into design is again super valuable, because I think one of the real benefits of GraphQL, and one of the things I'd hate, like talking about kind of request complexity, I'd hate to lose it, because people started building an API and then discovered that it causes problems when people use it. It's like, well, it's not your users' problems. That's your problem. They're trying to do something useful. So figure out a way to solve it for them efficiently, and the work that you're putting into your API just becomes more and more valuable for your company or your users. So moving on, the last one we're going to talk about is kind of this authorization plus. And this is, the reason why this is a concern with GraphQL is that, one endpoint has access to the entire graph. All the fields in a type by default, you can get at those and see those, and queries and mutations, reads and writes are happening through the same HTTP, maybe not the same request necessarily, the same endpoint, same endpoint and method, right? I can send a post with a query in it that retrieves something, and even at the same time, I can fire off a mutation. So simply authorizing at the kind of the HTTP level request is not enough. I need to be able to understand what the nature of that GraphQL query or that GraphQL operation is. And there are some pretty straightforward, I think, recommendations on ways to do this, and some of them are easier or harder to implement depending on the solution that you're using. I think with REST APIs, I really liked API keys because they were so easy to deal with. And a lot of the companies that I was working with, it was not necessarily a concern to get that end user authorization all the way down to the REST API. It was generally, hey, is this application that we're going to be building needs to call this endpoint. In some cases, you might pass in some user context to restrict what data came back out, but generally API keys were really nice. They're easy to test with, easy to revoke. It's a simple kind of a thing to just yank it out. I'm starting to come around to user authentication and specifically using JWT for user auth and authorization, I should say. So authenticating a user and using that token as an authorization item essentially allows you to create a sort of an attribute-based access control policy on top of your graph. So I can put attributes in the token that say, this user is allowed to request order information, or this user is allowed to introspect my GraphQL API, and this set of users or this class of user is not. I can build those attribute-based rules and apply them at a very granular level into my graph. And that gives me the ability then, regardless of kind of validating the HTTP request or validating the GraphQL operation that's coming in, I can rely on my server then to say, before it's going to return any data, it's going to validate that, oh, yep, this user can request this operation. This query operation is okay for this user. But this field that they have in there is not. So we're going to reject the whole thing. And I think building a system that allows you to do that, like you said at the beginning, Sridhar, actually can create a much more secure system if you combine kind of that attribute set, that rule set with your schema and do that softly.
Exactly. And a very important point here is don't protect things that don't need protection, right? The big, protect everything approach also is expensive, because protection really is not cost free.
Mm-hmm.
Right? If something doesn't need protection, people are not going to go and grab that information just because it's unprotected. If it is unprotected, it means they can get the information when they need to. And if the information is not worthy of protection, in the sense that it's not somehow personal to someone or anything of that kind, which mandates you to protect it, then it's completely okay to have open access. And actually, open access information information silos are very rarely attacked, because there's nothing to gain from attacking them.
Right.
So it's a very good best practice to be thoughtful about deciding what needs protection and what doesn't.
Yeah, that reminds me a little bit about kind of the code that you don't write doesn't have bugs, right? So
yes,
the security rules that you don't have to create don't
create problems. Yes,
don't create problems. Yeah, I think that's a really good point. And so thinking about, especially with some of those attribute-based access control systems, security rules need to be complex. Maybe not complex. They need to be specific, because you can't have ambiguity and have a secure situation. So you need to have that specificity. But because of that, that means if you're putting rules on everything, even stuff that doesn't need it, you've got a lot of redundant rules in place. You've got a lot of spots where a stray keystroke can cause a problem. All of that stuff. So that's a point very well taken. At least for me, all of the code that I don't write is really good. So let's take a look here. Okay. I was going to show you a quick example of some of this at this point. And just to review, we talked about, and this was going to be primarily around GraphQL security. So thinking about either complexity of the requests was what I was going to show you. And then I don't want to spend a ton of time on demos, because it's going to vary depending on how the product works. But let me hop over to a schema and show you sort of one of the problems that can come up from an auto-generated schema. So for example, in this case, we've got a customer type. This is coming from a database. So there's a customer table, with an ID field in it. There's an order table that also has a customer ID field and a key relationship to that. And then what the auto introspection has done is said, oh, well, customers have orders, so I'm going to add a field to orders that allows me to go down in and run a query to get the orders for that customer. And then orders have customers, so I'm going to add a field that allows me to get the customer for an order, which is nice in terms of thinking about what might be possible. So let's just make sure this is still live and I can make these requests. What this allows me to do then is, in my GraphQL schema, and I don't have introspection turned off, so it'll auto fill things for me. So I can say that, I want to see the orders, and I want to see, like, say, the order. Is there a date? Yeah, and a status. I'm going to prettify that thing up a little bit and send this off, and we can see that I can pull this up. Now, but because orders are linked to customers, I can go back to customer from this and say, oh, what's the customer name? And what orders does that customer have, even though it's the same customer, right? And you can see that I can start to do kind of the same thing. And this is an example of, eventually I could continue this and continue this, and it would fall all the way down. Now it's going to generate load on your server just to actually put this together. If your server isn't smart about recognizing that this order or this customer is the same as this customer, it may be making database requests. This could be really bad, right? In the case of StepSend, we actually memoize these fields, so we know that we've seen customer ID before, and so when we ask for it down here, it doesn't make a database call for it, but it's still a concern because this doesn't make sense to me from a designer. I don't want someone to be able to put this nested query all the way down there. So I want to spend a little bit of time being thoughtful about how I design that. And maybe what I do is I say, well, I don't actually need to get this entire customer object from an order. Maybe all I care about is the customer name. So let's change this, and let's just make that a string. And instead of the query using customer, I'm going to say I just want the name field of that customer. And once this guy redeploys here, now I've got an updated schema that I come back over here. If I refresh my schema, I can see it instantly flagged this as a problem, right? It's not going to allow me to make this request because it says, hey, customer is actually a string. So I can't do that nesting anymore. So if I take this out, now I can still get customer information. I can get the customer name, but so I've been thoughtful about it. So if I had a different query where, say, I wanted to get orders and I wanted customer. So rather than, this is a different part of the app, for instance, that needs to show customer name. Normally I would just have order or customer ID in there and I have to do another lookup, but I can be thoughtful about this, and I can say, status and order date. And then if I fire this query off, I can still get all my orders. I can still get a nice customer name, but I'm not able to do that kind of deeply nested capability. And this is an example of kind of being thoughtful about schema design and thinking about opportunities for someone to cause trouble and just preventing them. I'm not restricted in sort of capability. I can still get information about the customer, and there are other ways that I could do this. I could get more complex. I could say, if I'm pulling in order or customer data from an orders query, I don't, that orders field isn't included in that path through the type, so I can kind of control those edges of the graph so that I prevent people from doing the sort of things that I don't want them to do. So that's a really simple example of how this works. And I know we're running a little bit short on time, but I did an example of what a access policy might look like for preventing certain things. This is the way StepSend does it. Other tools do it differently. But in this case, I've got some rules that I have uncommented. If I uncomment this one, we'll see that I've essentially disabled introspection by disallowing these fields on the query type. So now, regardless of what comes in, this condition false says you can't do it. I could change that to a condition of a JWT attribute that says, oh, introspection is a flag in that user's token, and so that user making that request can do that. You can do the same type of thing then on instead of just query types or mutation types, you can actually have fields in there, and I can control who has access to what fields of a type, who has access to types, all based on attributes of that token. And that's kind of an example of how we would implement that policy, attribute-based access control policies on top of our schema. And you can see these rules, while they're relatively simple to write, if, as Sridhar mentioned, if I had to do one for everything, this field, this rule set gets pretty large and it gets harder to reason about. So making sure that you're basically worried primarily about the things that matter is key to a successful implementation there. Oh, I lost my window.
So I think, Carlos, this example reminds me of of a situation that I was involved in, where something very simple was written in code, and not kind of just described using a system like this, but was implemented inside of an engine, and it was written in JavaScript. And it went through a proper code review process and so on, but there was a true which should have been a false. Right?
That's an easy mistake, right?
It's an easy mistake for anyone to make, and you can't blame the person who made it, right? But that had the net impact of opening up to anybody in the world the account of anybody else.
Ooh.
Right? The fact is that logical errors are very, very, very hard to avoid, right? And so it's a story, right? The fact is that these stories are not common, but they are not uncommon.
They're not uncommon, yeah. Yep.
Right?
Absolutely.
And so one of the one of my abiding principles is always to try and have a place where you specify your security things, which you can reason about independently from all the other logic, all the other functional logic that you write about your your stuff. And so when you showed that that security configuration, I got reminded of that story and saying, hey, look, you talked about how you design your API beautifully. That's a great thing, and how designing it well helps you build a better security posture. But at the same time, I was able to go in and see what your security configuration was, all in one place.
Yeah.
Right. And so if there's a failure in security, I know where to go and look first.
And and
I know where to go look to see what changed. Right, rather than have to see, okay, what are all the lines of code that could have changed last week.
Yeah.
So I give this advice to programmers: even if you're writing your security stuff as code, make sure that it's all in one place where you can go reason about it, think about it, and try and keep it clean. And not embedded somewhere else. So I think it's
so even if you're writing your resolvers, using one of the languages, Go or JavaScript, maybe it's a great idea to have a configuration-driven approach to that security, so that the resolvers are reading from that before applying, when they apply.
Yes, and things that changed regarding your security are all in one place. And
all
so when something breaks, you can go and look and say, okay, these are the things that have changed. So one of them may be the cause.
Yep. And then I think the other nice thing about that I'll just reiterate again as I jump on is that testing a lot. Once you start to do that, right, you can make sure to write tests around security so that an accidental true or false doesn't get out the door, because you've got tests that look for the simple stuff, right? The simple mistakes that everybody ends up making at some point. You shouldn't. The mistakes will continue to happen. We can't necessarily fix mistakes in general, but having tests in place allows us to really limit the blast radius of that mistake, right? Yeah. So again, to wrap up, we don't think GraphQL is less secure. It's actually, as Sridhar eloquently pointed out, it's probably more secure if you think about security from the start, and if you think about it in sort of a holistic perspective, in combination with the schema that you're building, it really gives you a great deal of control. And of course, designing your schemas thoughtfully, thinking about security is how you execute that control, and then of course testing it, validate that the controls you're putting in place are correct.
Yes, and if I want to add one thing to that list, I would say that remember that every line of code you write is a possible bug, and so don't try to write code if you don't need to. Try not to write code unless you need to.
That's a great way to put it. Try not to write code unless you need to. So for everyone on the video or on the web stream and watching the video later, there's more that you can learn about, what we talked about here at these bits of these links. This video will be posted on the YouTube channel, so you can come back and look at it and hit pause to find the right ones. But our blog has a bunch of information about this, and we're continually, trying to sort of spread the word about the power that you get with GraphQL. I think it's really beneficial and exciting to see it starting to take on more and more. So now I know we're running a little bit longer than probably anticipated, but if there are questions, we'd be happy to address them here, or let me pause that there, and I'll just quickly change my sweatshirt and put on a hat. And Sridhar and I are here to deal with any questions that might come up. I know we did.
It looks like I'm wearing the same sweater as I wore. That's why I was noticing that. And,
you planned ahead. That was smart. I did not. But I just wanted to thank everyone, of course, for hopping on, and do please, as I said, hit those links and check out StepSend if you haven't before. Have a nice day to you too. Thanks for jumping in. That was a comment that came in there at the end. If you have any questions, we're still here. This is live, and would be happy to answer anything that comes up. I was just trying to think, Sridhar, if there's anything. I know it hasn't been that long since we did that, but if there's anything that has changed recently in what I would say about what we talked about there, and I don't think that there is. I think for the most part, we didn't go too specific into any unique security cases that would have changed anything. I do think that based on the companies we're talking to and the adoption that we're seeing, I think it is GraphQL adoption continues to have a bunch of momentum behind it. Yeah. And I think the one thing I would say maybe we could have talked about a little bit more is thinking about federation of GraphQL APIs and security concerns around that.
Yeah, so that's very pertinent. I think the thing that I've realized, is that GraphQL, the GraphQL journey inside of companies is a continuous one. People don't do GraphQL, box it, and be done. Right? Mm-hmm. The API evolves, and as the API evolves, so do the security concerns that need to be addressed as part of the API, right?
Yep.
And it makes the design-led philosophy that we talked about in this presentation even more important, because if you did not think about security in your first iteration, your second iteration becomes more complicated. And if you did not think about security in your first two iterations, your third iteration becomes impossible.
Even worse,
right?
Yeah.
And so you've got to start thinking about. And by the way, this is not just GraphQL. This is APIs, right? Because APIs also, people who are attacking you for information, if they can call an API and write a bit of code, right, and reach out to another API, they will. It's not that that they won't, right? Because they have an incentive to do it. So in fact, kind of consolidating everything and having your security thinking hats on and thinking about it as a collective thing, as you said, about federation and so on. Thinking about all the information that your company is exposing and exposing it all through a single federated data actually makes the whole thing far more robust and allows you to put a policy framework in place and a way to start thinking about security as an end-to-end thing rather than piecemeal decisions that are made by different people across different teams and who may not all have the same context.
That's one. Yep, that's we probably would add a slide or two about that. And as you were talking about that, I started to think about some of the stuff we've been talking about recently with sort of the data warehouse approach that we're seeing now. We've got a few people doing things with Snowflake, for example, where it's not just I built a service, or I've got a set of microservices I want to federate, and I'm worried about security. Then you may have someone that comes in a little bit later on and says, hey, we're doing terrific analytics on our data warehouse. We'd like to get that exposed to our application so that our customers can benefit from it. If you're not taking that holistic approach of understanding everything, that's a spot where you want to be really careful about what you expose, because that data warehouse possibly has everything that, if you're really buying into that, you're pushing all sorts of data into that. So you can't just drop an introspection on it and say, hey, give me everything that's in the data warehouse, and now I can do a GraphQL API on it. You really need to think about the specific entities that you're going to be sharing and the capabilities that you're going to put out there. So that upfront consideration, I think, is just more important than it was, a few months ago, probably.
Exactly, because the richness of the data that is becoming available, not just through GraphQL APIs, but through APIs in general, it is entirely possible that your company may be exposing a GraphQL API and a REST API and maybe a third API, of programmatic in some other way, right? And really, there's someone who's convinced that they need to attack you is not going to limit themselves to using one or the other.
Right.
They're going to use all of them at the same time. And so thinking about security across your suite of APIs is already an issue. It's not an issue that has happened because of GraphQL. It's already an issue.
Yep.
GraphQL makes it easier to solve it.
Yeah.
Right? Because it forces everything to go through the same thought process. That's I think, that's I think a big lesson.
Yep. Very good stuff. Very good stuff that we can add to version 2 that we'll do in a couple of months. We'll have some new content to line that up with. Well, if there are no other questions, I think we can put a wrap on this one. I'd like to again thank everyone who hopped on and took a look at what we were talking about. If you haven't tried StepsN, visit stepsn.com, sign up for an account, and give it a whirl. Reach out to us on our Discord. We're always happy to have conversations there. So thanks, everyone. Have a good afternoon.
Thank you.